All right, I'm glad you are here along with us today, tuned in, because we have an exciting program for you today about a fascinating topic with an interesting guest. Lynne McTaggart is with us. She is the author of The Field, The Quest for the Secret Force of the Universe, and her latest book is entitled The Intention Experiment. Lynne also was a part of the film What the Bleep Do We Know, and she also appeared in the follow-up film Down the Rabbit Hole. Very interesting stuff. And Lynne is also coming to Sweden this weekend, I think, and she's going to attend a conference in Stockholm. And we're going to mention that a little bit later on, so you guys out there interested in that can find out more how to attend and so on. The website that you need to take a look at is livingthefield.com. Really nice site with lots of info up there for you. And I know that Lynne is really busy, and we got about an hour here today, so I really want to get right to it, as it were. So let's say hello and welcome to Lynne McTaggart. Thank you for coming on and spending some of your time with us today.
It's a delight to be on your show, and I'm very excited about coming to Sweden. It's my first time.
Yeah, it is, huh? Interesting. Why not begin there? Tell us about it. When is it and so forth?
It's called the Quantum Energy Medicine Seminar, and it's in Stockholm on the 5th and 6th of May, and I'm there on the 5th speaking in the morning. So it should be very exciting. It's the Zed International show.
There we go. Do you know how much are the tickets, and are they available still?
I don't have details. I think there still are some tickets available, but I think people can find out on the www.xede.fr site.
Okay, well, very good. People can go there and check it out for themselves. So, yeah, as I said, very exciting to have you here. Awesome. Before we dive in and talk a little bit about the field and, of course, your latest book, The Intention Experiment, I'd really like to begin a little bit, talk about you, kind of what attracted you to this research and when you first kind of got into the field. No pun intended there, but what interested you in this subject, Lynne?
I do a newsletter called What Doctors Don't Tell You. It's a monthly newsletter that looks at the conventional medicine, what works and what doesn't in conventional medicine, and also alternative medicine. And I study medical literature to see if there's any scientific evidence for conventional treatments or orthodox treatments, and also if there's any evidence for alternative treatments. And so I've been doing this for a number of years, and I kept coming across studies of alternative medicine like spiritual healing and homeopathy, demonstrating that this stuff works. And I kept thinking to myself, well, if the evidence shows that this works, then something in our understanding of the way the world works must be incomplete. And so I kept thinking to myself, something in our understanding really is wrong about the way the body works. If you can be in one place and send a mental intention to someone else to make them heal, as spiritual healers do all the time, and if that can be demonstrated to work, then our understanding of the body is really incomplete. So I convinced my publishers to let me go on a journey around the world, interviewing frontier physicists and biologists and other scientists to see if they had any idea of why this could be so. I really didn't know what I was going to find. This was an open-ended journey. And what I discovered, and I was amazed, was that each of these scientists working in their respective fields had one tiny piece of the puzzle. And it soon became apparent to me that I was going to have to put this puzzle together and synthesize it to see if we could, to see if there was a new view of reality. And indeed, there seemed to be that these guys were all on a paradigm shift. They were all looking at a very new view of the world that basically drove a stake into the heart of conventional science.
Nice. Tell us about some of the people you talked with on your journey.
Well, I think the hero of the field is a guy called Hal Puthoff, who's a very mild-mannered physicist who was looking for an alternative to fossil fuels in the 1970s. And he thought about one overlooked area of physics that all physicists know about. It's a quantum energy field called the zero-point field. And what it is it's created by the little energy dance that goes on between subatomic particles. All subatomic particles send out energy to other subatomic particles. It's almost like passing a ball back and forth. And the one subatomic particle will pass energy out, and another one will receive it, and then they'll send it back. And this little endless energy dance produces an unbelievable, unfathomable amount of energy. You know, if you consider one pass back and forth, it's only about a half a watt of energy. But if you count up all the subatomic particles in all the things in all the world doing this energy dance, you come up with this enormous, just indescribable energy field. Now, we call it 0 point because this energy dance goes on even when things are slowed down and so cold that they go to absolute zero. And that's the thing that is, even at 0 point, it still goes on.
Interesting. In your book, I think you mentioned that you tied this together in a way with both inertia and gravity, right?
Hal Puthoff certainly did.
He did.
realized that if you took account of, the 0 point field has always been subtracted out of most equations, physicists' equations, because it messes up their math. And so they cut it out. It creates infinities. So they cut it out. But Hal realized that if you keep it back in, if you don't subtract it out, it will provide answers to things that have always been assumed to just be dictates of physics, or laws of physics without any explanation, like inertia, which is, that is the force in the universe that makes things hard to get moving. And once you get them moving, you can't stop them, And also, gravity, you could count gravity as perhaps a 0 point effect. So he actually published papers about this, arguing for this. But he also realized that there was a big metaphysical implication of this ground state of quantum energy. If there's a quantum energy field made up of all subatomic particles, it means that we're all united by one invisible web, and also that we are in connection and can be in touch with the furthest reaches of the cosmos through this field. So Hal realized there was a very important element here, and it could explain many of the things that we have found unexplainable, like how people pick up information at a distance, how people have an effect on living reality, with their thoughts, things like that. So the quantum energy field seems to be the central explanation for many of these intuitive effects and many of these ideas that native traditions have understood but never had a scientific explanation for.
Interesting. For someone who kind of is up to speed, as it were, with the basics of quantum physics and so forth, is there any way to kind of boil this down in a fairly simple form? Is that possible?
Yes, absolutely. There are a couple of basic ideas that make these discoveries so interesting. The first is the idea, and I elaborate this on both books, particularly in the newest book, The Intention Experiment. In the quantum world, we understand there's a thing called superposition, and basically that means that a subatomic particle isn't a set entity; it's all possible cells. It's just a potential. So what that means is imagine a theater. And imagine a single seat in the theater. Now, normally we think of a person or an entity or, any matter in the universe as occupying just a single seat. It's a set something. It's a finalized assemblage of something. But a subatomic particle isn't just that single seat. It's every seat in the stadium. It's every seat in the theater. It's all seats all at the same time, all possible cells. Now, what they've understood is the only way that all possible cells turns into a set something is when a scientist observes or measures it. And this is called the observer effect. It means that observation, living consciousness, is somehow intrinsic to making that potential of something real. So, but scientists have always thought that only occurs in the quantum world. That once a quantum entity begins being part of a bigger thing, like atoms and molecules, it starts behaving itself more like what we understand in, of Newtonian reality. Reality is described by Isaac Newton, that things require force, that things operating according to set laws of motion, etc. But latest studies have shown that that's not true, that even big things like atoms and molecules also operate according to these strange Alice in Wonderland laws, and that big things like molecules exist in a state of superposition. In other words, I'm not quite set something yet. And so that suggests to us that big things, the big building blocks of matter in our sticks and stones world are still influenceable. They are mutable.
Mm-hmm. So is this kind of what Werner Heisenberg developed, early on, known as the uncertainty principle? Is it connectable with this in any way?
Yes, it's absolutely connected with that. It's the idea that you could never, that electrons or subatomic particles are ultimately unknowable because they're a potential. They're not a set something yet. And now we understand that what Heisenberg thought was just applicable to the quantum world is actually applicable to the world at large. And so this, to many people, makes us understand that our equipment, we haven't had equipment sensitive enough to measure this. Now we do. But it suggests that matter is mutable, that matter is influenceable by the power of thoughts and by living observation. There's another element in this that's very important, which is the whole idea of non-locality. And this word non-locality and entanglement, which is a nice poetic way of calling it, has been always thought, again, to be a quantum effect. And what this means is, it means that there's an instantaneous connection between two entities, no matter how far you put them apart. So let's say, I always say it's like twins separated at birth. If you take one and you put one in Tokyo and the other one in New York, even though they've never seen each other again, they act identical at the same time, so that they both might marry a woman called Jane. They both might like the color blue, and if one falls down and breaks his leg, so does the other one, even though the first one may be skiing and the second one may be just sitting there drinking a coffee in Starbucks. So it's that kind of instantaneous connection and effect occurring across time and space, always, forever. And that is what we know happens in the quantum world in non-locality. But we are now discovering, and scientists are now finding out, that this occurs in the world at large. This occurs among atoms and molecules again. They create non-local effects. They have instantaneous connections that sometimes override big effects from the outside, like the application of heat or a magnetic field. Things being non-locally affected are operating according to their own internal laws. And so this is, again, demonstration that we are probably far more connected to things out there than we have understood, that we are all connected somehow.
Very interesting. This is about, in a way, communication in a way. And the interesting thing is that the question is, I guess, what it is, because inertia in regards to even light, that things can't travel fast enough. Let's say if we move two things apart, way apart out in space somewhere. But what you're saying, I guess, is that there exists a kind of a communication between them, no matter what the space is. So the question kind of is, what the heck is that can travel faster than light and faster than anything instantaneously, I guess.
Well, what it means is probably Einstein was only part right. Remember, you always have to think of science as a process. It's a process of discovery, and sometimes we get it, and then we move on a little bit further, and we don't, we need to get more. We outgrow our understanding, so we have to understand some more. And so Einstein understood something that seemed very important, but there's probably more to the story, and that's just unfolding now.
It is, yeah. How about, being consciousness itself? Thought is almost an instantaneous way. We can travel